It is made to simplify the computations involved, and in this sense it is considered naive. Hello all, welcome back to Being Passionate Learner. I'm Dr. Padmapani Tribhuvan. In this video, I'm going to discuss naive Bayesian classifier. These are the contents of the video. What is naive Bayesian classifier? Assumption. How does it work? If you are interested in a solved example of naive Bayesian classifier, you can watch a video on it. Its link is given in the description. Let us start with what is naive Bayesian classifier. Bayesian classifiers are statistical classifiers. They can predict class membership probabilities, such as the probability that a given tuple belongs to a particular class. Bayesian classification is based on Bayes' theorem. Bayes' theorem states that probability of H condition on X is equals to probability of X condition on H into probability of H divided by probability of X, where probability of H condition on X is the posterior probability of H condition on X. Probability of H is the prior probability of H. Probability of X condition on H is the posterior probability of X condition on H. Probability of X is the prior probability of X. Assumption. Naive Bayesian classifiers assumes that the effect of an attribute value on a given class is independent of the values of the other attributes. This assumption is called class conditional independence. It is made to simplify the computations involved, and in this sense it is considered naive. Now let us see how does it works. Let D be a training set of tuples and their associated class labels. Each tuple is represented by an n-dimensional attribute vector x is equals to x1, x2 up to xn, depicting n measurements made on the tuple from n attributes respectively a1, a2 up to an. Suppose that there are m classes c1, c2 up to cm. Given a tuple x, the classifier will predict that x belongs to the class having the highest posterior probability condition on x. That is, the naive Bayesian classifier predicts that the tuple x belongs to the class Ci if and only if probability of a Ci condition on x is greater than probability of Cj condition on x for 1 is less than or equal to j is less than or equal to m, where j is not equals to I. Thus we maximize probability of a Ci condition on x. The class Ci for which probability of a Ci condition on x is maximized is called the maximum posterior hypothesis. By Bayes' theorem, probability of a Ci condition on x is equals to probability of x condition on Ci into probability of a Ci divided by probability of x. As probability of x is constant for all classes, only probability of x condition on Ci into probability of a Ci need to be maximized. If the class prior probabilities are not known, then it is commonly assumed that the classes are equally likely. That is, probability of a C1 is equals to probability of a C2 is equals to up to probability of Cm, and we would therefore maximize probability of x condition on Ci. Otherwise, we maximize probability of x condition on Ci into probability of a Ci. Note that the class prior probabilities may be estimated by probability of a Ci is equals to Cit divided by d, where Cid is the number of training tuples of a class Ci in training dataset D. Given datasets with many attributes, it would be extremely computationally expensive to compute probability of X condition on Ci. In order to reduce computation in evaluating probability of X condition on Ci, the naive assumption of a class conditional independence is made. This presumes that the values of the attribute are conditionally independent of one another given the class label of a tuple. Thus, the probability of X condition on Ci is equals to product of k is equals to 1 to n probabilities of Xk condition on Ci. In order to predict the class level of a x, probability of x condition on Ci into probability of a Ci is evaluated for each class Ci. The classifier predicts that the class label of tuple x is the class Ci if and only if probability of x condition on Ci into probability of a Ci is greater than probability of x condition on Cj, probability of a Cj for 1 is less than or equal to j is less than or equal to m, where j is not equals to I. In other words, the predicted class label is the class Ci for which probability of x condition on Ci into probability of a Ci is the maximum. If you want to know how to solve problems of Neo-Bayesian classifier, you can watch video on it. Its link is given in the description. Thank you for watching this video till end. See you in my next video. Till then, be passionate learner. Keep learning. Thank you.